Today on Aqua Kids.
Come join the Aqua Kids and learn how climate change is affecting the fragile ecosystem of the estuary and the consequences of sea level rise.
Aqua Kids, doing what we have to do. Saving our earth, land, air, and sea. All we gotta do is keep it green and blue. For me and you. Aqua Kids.
Hi, I'm Anna Jones. Welcome to Aqua Kids and back to the Goodwin Islands. Willie Ray is going to tell us more about this vulnerable habitat. So tell us a little bit about the work that you do here with the marshlands.
Okay. A lot of folks have a lot of interest in wetlands, but today there's actually a threat that we're very concerned, and that is related to climate change, and in particular in our area in the mid-Atlantic is sea level rise. So today what we're going to try to do is show you a little bit of the work we're doing out at Goodwin Islands to see if indeed sea level rise is having an impact out here, what's the scale of that, and with the ultimate idea of what can we do about that and maybe translate that to other areas.
Can you show us a little bit of what you're doing?
Sure. So what we're going to try to do is see how the marsh is responding to the rise in water level. And that's the main question is this marsh going to be able to keep up with sea level rise, or will it become inundated, become a new habitat such as offshore? So let's go ahead this way and we'll take a look at what's going on here. So we wanted to talk a little bit about sea level rise and why it's a concern here. And so pretty much on the whole Atlantic coast of the United States, this is the area that is most susceptible, and that's for a variety of reasons. So what we have going on here, if you're looking at sea level rise, it's a fairly complex issue, but we'll break it down into a number of processes that are occurring. And so the one that you typically hear about, the global process, is the warming of the water and how it expands, takes up volume, which would raise the water level. The second is, as you know, as the air temperatures are increasing with climate change, we're seeing melting of our ice sheets coming in off the continental landmass, and that's going to raise the water levels. Some of the things that are happening a little bit more on a regional and a local level, which some folks may not know about, is land subsidence plays a heavy role in the mid-Atlantic here in the Chesapeake Bay area. Back about 18,000 years ago, there was a very large ice sheet on the North American continent that came down as far as our present-day Pennsylvania. It did not get down into Maryland and Virginia. So what that meant is you had so much weight sitting on the land up north of us, pressing down, what caused our land down here south of that glacier to rise a bit. When that melted, what happened is, first, a lot of water came in, causing sea level rise, but also that land underneath the glacier went up, and guess what happened to us? We went down. So it's all reaching equilibrium. That's a very large component of sea level rise in our area. Also, there's some recent work going on where the Gulf Stream is now weakening to some degree, and that's having an impact on the Chesapeake Bay. When the Gulf Stream was flowing north, water, based on the way water moves towards the right. And when that weakens, it's going to kind of come back our way towards the land, to the mouth of the Chesapeake Bay, and guess what? Raises the water level a little bit into the Chesapeake Bay area. So we have a lot of interesting processes going on, some that we can directly control, some that are going to be a little bit harder for us.
Well, if the Gulf Stream is weakening, how does water get pushed around?
Great question. So what you have is the Gulf Stream is coming up north along our coast, and what's driving that system is as that warmer water, less dense water is moving up our coast because it's warmer, and it starts now getting into the colder regions, it's going to become dense and drive down. Just think of it sort of as a conveyor belt, driving the surface waters and then dives down. What's happening with climate change now, though, is we're having fresh water coming in from the ice sheets, and also we're having warming of the water. Both of those processes are going to make the water less dense up north for us. So that driving force has been reduced. And what that means is when water is moving, let's say north, typically water will pile up at about a 90-degree angle to the direction it's moving. And so that means it's piling up off our coast as that water's moving north. If we weaken that force, that water will want to come back on itself, and that way enter the Chesapeake Bay and cause some of the rising of the sea level that we're seeing here.
So what happened to the trees over there?
Okay, so you're looking at a bit of a time capsule here. So let's go back to that 18,000 years ago. You know, sea level was way down because the water was tied up into the glaciers. Okay, so this was all forest over here. This was all uplands. And then that water has, as those glaciers melted, the sea level rose, okay? So this was all forest that eventually was inundated and then became salt marsh, and that's what you see behind you. They're exposed because now we're seeing one of the processes occurring out at Goodwin Island, which is erosion.
Is this marsh equipped to handle any degree of sea level rise, or is it going to become inundated like the forest before it?
So that's the big question that scientists and research managers are looking at right now, and that's what we're going to be showing you out here at Goodwin Island. So yes, the marsh can handle some degree of sea level rise, and so that's the question. We're going to show you how we're measuring that, and we're going to be able to say if this marsh is going to be able to sustain itself or what's going to be happening here.
Great information, Willie. Okay, what marsh facts have we learned?
Well, sea level rise is caused by two major factors. The first is rising air temperature, which melts the glaciers and expands the water. The second is the land sinking.
We also learned that this is one of the most vulnerable places in the country when it comes to sea level rise.
Sea level rise is accelerating.
Don't go away, more when we come back.
Now it's time for Aqua Quiz with your host, Drew Cruz.
I haven't eaten since lunch. I'm your host, Drew Cruz, and now it's time to test your knowledge with Aqua Quiz. Sea level rise is becoming a critical concern for many parts of the world. Can you identify factors that may be causing sea level rise? Are they A, melting of polar ice and glaciers, B, increased storm activity, C, ocean temperature rise, or D, all of the above? I'll have the answer after the break. Do you know the key factors causing sea level rise? The answers are A and C. The melting of polar ice and the expansion of water due to warming temperatures are the main factors behind sea level changes. I'll see you next week with another Aqua Quiz.
Welcome back to Aqua Kids. Now we're going to learn how they measure the change in elevation here in the marsh. Hey!
Hi, Hannah. So we're very interested in sea level rise at Goodwin Islands because the elevation change from the marsh edge up until the forest habitat is very small, maybe on the order of half a meter to a meter. So with the sea level rise estimates that you've heard about before, that creates probably quite a challenge for this habitat. So in order to measure changes in the marsh habitat at that very high accuracy levels, we need very sophisticated surveying equipment, a technique that was traditionally used on land and now brought into these challenging coastal environments.
Can you show us some of the equipment?
Absolutely. One piece of equipment that we use often is GPS equipment. That stands for Global Position System Equipment. And this piece of equipment specifically is called RTK, or Real-Time Kinematic Equipment. GPS allows you to uses satellites to get precise elevations on the Earth's surface. So what we're concerned about is making sure we understand any change in elevation on the land and how that relates to the water. So with this equipment, and I can measure a point here in this marsh, I can measure a point out in the forest, I can measure a point out in the water using our YSI, and we know all those measurements are on the same reference frame. So it allows you to relate one measurement to another.
With that data that you have, what's the difference in elevation from the forest to the sea?
Well, here at Goodwin Islands, the typical elevation for our forest habitat is at about 0.78 meters. The edge of the marsh surface here, typically at Goodwin, is about 0.2 meters. So basically that difference, 0.6 meters, is about the difference in change from the forest habitat to the marsh edge.
That's not a big elevation difference between the forest and the sea. It's only a matter of time before it reaches the top.
I agree, and that's why we're very concerned about the sea level rise effects on our marsh habitats at Goodwin Island with that small elevation. Models in this area have indicated that we could only have 5 to 10% of remaining habitat here at Goodwin Islands by the year 2100. And our goal, we feel, is to take the information out in the field and to see if those models are accurate.
So how do you possibly measure a marsh?
Well, let me show you.
Okay.
Aqua Kids will be right back. Welcome back to Aqua Kids.
Let me show you guys how we measure marsh elevation change. And this is extremely important because what we're basically interested in is what is the tidal frame out in the water, and then if that tidal frame is changing due to sea level rise, then what impact is that going to have on the marsh surface? And if we know the impacts on the marsh surface, then we can look at impacts to the plants and try to put the whole equation together.
Okay, so what do we have here?
Well, this is a surface elevation table, and let me explain this real quickly. So this whole plot is an area of measurement for measuring marsh change, and the reason we have this boardwalk structure is we don't want to step into the area and cause any variation in our estimates, our measurements. So the actual surface, I'm going to step over here, the actual surface elevation table is this structure right here. And let me explain quickly what this is. So what we've done is we've taken stainless steel rods and threaded them together and driven them down basically with a jackhammer till refusal. So we've got a solid mark to bedrock, we hope. And then we attached a receiver to those rods that'll take our instrument, and then we cemented everything so everything's in place. So this is the two pieces to this surface elevation table instrument. This first part is the head, and that just screws onto the adapter.
Okay.
And this second part is the arm to help measure. And there, you can see there are 8 holes, and so we can rotate these into 8 different positions, this arm. So now we would just level the instrument, and now we're ready to place our pins down to the marsh surface. So to do this, and it's always a little uncomfortable, but we take our pin, and can you see this, guys? And we take this and we basically find that marsh surface, set it gently, and then place a clip. So now this is the distance that we would measure every time we come out, and we do this twice a year. And so now we can see the change in this distance and know whether we're losing marsh or gaining, losing marsh surface or gaining marsh surface at this particular place.
Okay.
So how long have you been conducting this survey?
Well, this particular SAT has been in for about 7 years.
Wow.
And the trend that we're seeing at this site is accretion or positive elevation change of the marsh surface of about 1.4 millimeters a year. That sounds great, marsh is growing.
Yeah.
However, if you remember, relative sea level rise in this particular region is about 4 to 5 millimeters a year and accelerating.
So it's like
So,
not fast enough.
right, so we're predicting that over time we would lose this habitat at those sea level rise rates.
So what is that tank there for?
Well, we've already seen numbers of marsh elevation change from the SET, but to understand those numbers a little bit better, we need to look at some of the processes that are contributing to that change. And one process we can look at is marsh accretion, or how much the marsh is growing either through inputs of sediment or through growth of the plants themselves. And we can do that through a technique called cryogenic coring, where we can produce a marsh popsicle. So here we're going to measure sediment accretion. You can measure sediment accretion a number of ways. Sediment tiles measure daily sediment accretion. You can do lead 210 dating, which measured on a 30 to 50 year time frame. But this gives us a yearly trend in sediment accretion. So this is called a cryogenic coring technique. And so this is a tank of liquid nitrogen. This is what we call a marsh bullet. And so I'm just going to stick this into our marsh surface here, and in this plot, when we installed the instrument, this SET instrument, we laid down a layer of this white shiny clay, feldspar clay. That's our marker. So what we're doing right now is we're setting this pop, I'm going to call it a marsh popsicle, or this bullet, to go down and find hopefully that white layer, and then we can measure that and know how much accretion's occurred since that time of laying down the feldspar clay.
So why do you need to use liquid nitrogen? Why can't you just put a core in there?
We could use a core. We could also just use a knife, but we found that those methods are a little bit sloppy, and we don't feel that we trust that data as much as with this method here. Now I'm going to turn on the liquid nitrogen gas, and this process will probably take about a minute and a half for the bullet to freeze. You'll start to see the liquid nitrogen running through the tube. You might see a little bit of gas coming off here. We can usually get about 20 to 25 pulls of bullets using this tank of liquid nitrogen.
Is it going to get cold?
Absolutely, which is why we come out with the gloves to grab this. I made the mistake once of not using the gloves, and only once will you make that mistake.
Is it supposed to do that?
Yes, that's what it's supposed to do. And when it starts spitting like it is, then we feel that has gotten to the point where it can be turned off. We can turn off the liquid nitrogen, and we now have this frozen bullet. So what we'll do is we'll go down and retrieve that bullet from the marsh surface. And this one we got the marker layer. It's a little bit, so what we do is we take a knife and you sort of smooth it out. Okay, so now, as you can see, there's that white layer that we were looking for. Here's the top of the marsh surface. So you sort of take a number of measurements to get an average to that white layer, but that would probably be, somewhere, I don't have a caliper with me, but somewhere in the estimate, area of 5 to 10 millimeters of accretion.
And that was taken a year ago?
Well, this mark horizon was actually put down 4 years ago.
Virginia right now is home to the second most endangered region to sea level rise by population. So we feel very strongly the presence of climate change and what that will mean for our state. These climate conversations bubbling up on our university, and a lot of us were starting to put pressure, resisting our coal plants, asking for divestment, raising support to bring renewable energy. We needed to start speaking to where these decisions were actually being made, and then looking in that direction and seeing it pretty void of the youth voice. It's much more difficult to actively put in place policies that are endangering our future when the room is full of young people. I started the Virginia Student Environmental Coalition, then working to fill those rooms with young people when it's the Virginia General Assembly, or we're talking about the Clean Power Plan, or when it's not just a platform, but it is a group of students that feel connected and stronger when they're together. You just put out one invite that's sent around to our universities, instantly had 60 people sign up from all around the state. A lot of people will stick around and they keep fighting when they're fighting with community. That's really where our deeper motivation comes from, is to shift that balance, to have a civically engaged, motivated youth force that is paying attention and showing up and engaging with all of these issues across the state.
What gives me hope when I interact with students like Diana is that they take something like, well, we can eliminate coal. And I think, really? We can eliminate coal? How hard would it be? And they say, let's get busy.
Anna here. For more information on today's show, go to aquakids.tv.
Aqua Kids will be right back.
Hey, it's Drew. Join the Aqua Kids next week as we uncover what's being done to restore the American eel population in the Susquehanna River.
I'm Jalen, and this is Earth Edition. Since the late 1800s, the Earth's average temperature has increased. It stems from people burning more coal, oil, and natural gas. It's only a few degrees, so why does it matter? It matters a lot. Climate change and sea level rise impacts every aspect of our existence. Agriculture depends on the weather to grow healthy crops. Our water supply takes longer to replenish with rising temperatures and increased droughts. More energy is needed for air conditioning as temperature rises. Our health is threatened due to heat waves, severe storms, air pollution, and diseases. Ecosystems depend on certain conditions for balance. Global climate change could cause flooding as the sea level rises. This could erode or completely wipe out certain beaches and islands. There are ways each of us can help slow the impact of climate change and sea level rise. Switch to clean energy like wind or solar. Use less energy by powering down equipment when not in use. Travel green, walk, bike, carpool, or use public transportation. And reduce water use. And reduce waste by recycling. I'm Jalen, and this has been Earth Edition.
Welcome back to Aqua Kids. We're going to learn a little bit more about how the change in sea level affects the marshes.
Hey Aqua Kids, we saw a lot today regarding how the vulnerability of salt marshes to sea level rise, and why don't we kind of go over and summarize a few things.
Great.
Okay, so I think the first thing that we talked a little bit about was the impact of sea level rise, or the rate of sea level rise in the Mid-Atlantic region, and particularly the Chesapeake Bay. We sort of learned at some of the highest rates in the nation. And just to put it in perspective, so by 2050, we're expecting the range of sea level rise to go from its current stand right now to an additional 20 centimeters at mean sea level, all the way up to 50 centimeters. So that's putting it up about right in this area here, okay? While some folks may not think that's a big deal, when you look over here, you can look at the variety of vegetation types over here. Those vegetation types are changing just on the relative scale of centimeters, okay, with elevation. So it is a big deal when you look at our natural resources, particularly how important marshes are as we discuss the fisheries, water purification, soil erosion, and flood control. The next thing we want to talk about briefly is sort of looking at the vulnerability of the marsh, and I sort of look at it as a patient. The number one thing is we want to look at, just as someone's coming in, is was that patient exposed to a stressor or to a disease or something like that. And so we call that exposure. And you know, from what you saw today, is do you think the marsh is being exposed to a stressor, and in particular sea level rise?
Definitely.
Definitely, yeah.
Yep. The interesting point is, and we have aerial photography going back to 1937, shows this entire area here was forested. So that can show you how rapid some of these coastal systems can change. Okay, and so what we're having back here, and I do like it, you know, Mother Nature is taking care of itself a little bit here. So we have exposure, We have the marshes sensitive to it, but the final thing is, and we talked about that with some of the measurements we saw, is the marsh able to do something, or as us, as coastal managers, can we do something to lessen that impact? And we saw the marsh has an ability, a certain ability to try to keep up with sea level rise. We found out in here we have some sections, such as the low marsh, is able to do that. However, when we get back into the marsh interior here, it is not keeping up with sea level rise. Another thing that we're seeing here also is, and perhaps maybe one of the best things that a marsh can do, but as us, as residents in coastal areas, we need to recognize that, is the marsh does have the capacity to move uplands. Okay, move into the upland environment, displacing forests and those things. That's generally okay, but if we put barriers, if there are barriers there, the barriers can be natural. It could be a bluff. Therefore, it cannot hop up meters, or it could be as simple as riprap or some sort of development activity that could stop its migration. So those are the things. In the meantime, our job is to try to keep these marshes as healthy as they can, reduce other stressors such as invasive species that we see back over here, nuisance species. We don't have them here, but you hear of nutria eating out areas, geese coming in, denuding an area, things like that. That puts additional stress on the marsh for it to stop there. So that's sort of where we're at. So we do have a part with active management of these marshes to help them retreat. I think is going to be one of our best options. So that's the message we're trying to take to coastal communities and resource managers.
All great information. Thank you so much, Willie. Remember, it's up to you to keep it green and blue. Help protect our planet, and we'll see you next time on Aqua Kids. Bye!
Aqua Kids plays an important role in increasing public awareness and energizing the next generation of scientists, policymakers, resource managers, and concerned citizens in helping carrying on our mission of preserving and protecting our coastal environment.